Hello students, in this question it is given that the nearest star to our solar system is 4.29 light years. So how much is this distance in terms of parsec? Parsec and light years both are the units of distances generally used to measure the celestial distances, the distance between two stars or two planets. And how much parallax, actually it is the angle that would this star show when viewed from two different locations of Earth. Let us visualize this first. Suppose this is the star S and it is observed from two different locations of Earth. Suppose this is the Sun and we are observing the star S from Earth. This is the Earth. And we are observing this star S from the Earth. As you know, Earth actually revolves around the Sun and it completes in what we can say 365 days. Now this is the A position of Earth and after 6 months it will be at B position. And this B position is exactly diametrically opposite to A. So this is the diameter you can see of the Earth's orbit. Star S is again observed from B location after 6 months. This position will be reached after 6 months. So this is also Earth and we are observing the star S again from the location. We need to find this angle which is known as parallax angle. Now the distance SB is given as 4.29 light year, or this distance again we can say that same, it is 4.29 light year, and this parallax angle theta, because Sun, this star S is observed from two different locations of Earth from A and B. This distance is 1 AU and this distance is 1 AU. So diameter of this orbit is 2 AU, 2 astronomical unit. Now we can say that now we have to represent 4.29 light year into parsec. Parsec is another distance, another unit of a distance. Again these are light year and parsecs are used for the celestial distances, the distance between two celestial bodies like Sun and Earth, Earth and Moon and so on. So we have to convert the light year into parsec. So first convert the light years into parsec. For that, what is mean by light year? So 1 light year is actually the distance traveled by light ray in 1 year. So whatever as you know, light travels with the speed of the light is 3 into 10 raised to power 8 meter per second. So with this speed, if it is traveling for 1 year, so that distance will be 1 light year. So 1 light year is equal to, that is the speed, that is 3 into 365 days, 1 year. Days has to be converted into hours and hours has to be converted into seconds. So 24 hours and 3600 seconds. And after this, solving this, we will get 1 light year is equal to 9.46 into 10 raised to the power 15 meters. So we got 1 light year. Now this light year has to be expressed. This light year has to be expressed in parsecs. 4.29 light year has to be expressed in parsec. So let us first get the conversion factor of light year into into parsec. So if we got this, we will able to solve it easily. So now let us express 1 parsec. As we know, 1 parsec is nothing but 3.08 into 10 raised to the power 16 meter into 10 raised to the power 16 meter. So if we want a conversion of light year into parsec, so we have to get the conversion factor, and for that what we will do, we will compare 1 light year with 1 parsec, and we will try to get the ratio of 1 light year and 1 parsec. So 1 light year is 9.46 into 10 raised to the power 15, and 1 parsec is 3.08 into 10 raised to the power 16. And after solving this, we will get a conversion factor that is equal to 3.0714 into 10 raised to the power minus 1. So we got the conversion from 1 light year to 1 parsec, or in another word, we can write 1 light year is equal to 3.0714 into 10 raised to the power minus 1 parsec. Therefore 4.29 light year, that will be equal to 4.29 into 3.0714 to 10 raised to the power minus 1 parsec. 1 light year is this much parsec. So 4.29 light year, that means you have to multiply it with 4.29 here both sides, 4.29 both sides, and we will get this equal to 1764 to 10 raised to the power minus 1, that is 1.31764. So I should write parsec. So 4.29 light year is equal to 1.31764 parsec. So this is the very important result for us. Now we have to find angle of parallax. If you refer that diagram once again, then we have to find actually this angle. Now the distance of that star from the Earth A location, or when Earth is at A position, let us find that angle first. If we are able to find this angle, then the required angle will be double of this angle. Now according to the definition of parsec, 1 parsec, it is the distance from the arc of 1 AU, and it obtained the angle of 1 arc second. So 1 parsec is the distance of any star from Earth, which is 1 AU distance, approximately 1 AU distance from Sun. So this is the definition of 1 parsec. So it is the distance of a star from the Earth, and Earth is at 1 AU from the Sun approximately. Actually actually we have to consider the arc length, but this arc length is much smaller compared to the 1 parsec distance. Now in our question, the star is 1.49 light year away or 1.317 parsec distance away. So let us apply the formula for 1 parsec. 1 parsec is created when angle is represented as the length of arc 1 AU divided by 1 parsec distance. That means distance of length of arc divided by length of radius. Now in our question, 1 AU, which is this distance, is divided with 1.317 parsec. So our angle theta 1, I have represented as theta 1, will be equal to 1 by 1.317, and this angle will be of course in arc second. This angle will be in arc second. 1 divided by 1.317, that will be equal to 0.7593 arc second. So theta 1 will be 0.7593 arc second. As we are considering this angle also, this will be again with the same dimensions. So this theta 2 will be again, when theta 2 is the parallax angle from the position B. So this will be again equal to the same angle, that is 0.7593. So total parallax angle, total parallax angle will be equal to sum of these two angles, that is 0.7593 multiplied by 2. That will be equal to 1.518 approximately arc second. So this angle is 1.518 arc second. So when the star, which is 1.317 parsec distance away from the earth, then the total parallax angle created from two positions of earth will be 1.518 arc second. Thank you.